Alright, so go ahead and copy down these 5 questions and work through them yourself. Make sure that your answers are complete. This will give you an opportunity to practice more polynomial division and also to notice a pattern. Make sure that you try and state your pattern in general, meaning for any polynomial. So the really important thing to recognize here is the relationship between the remainder that you get when dividing by this linear factor and the value you get when you plug in the constant term of your factor. In this case, the constant term is 2, x minus 2. When you plug in 2, you get the same value that you got for your remainder. Testing this out again, we divided this cubic by x minus 3. And when you plug in the value of the constant term, 3, you get 52, which is the same as the remainder. The pattern in general should go something like this. Anytime I have a polynomial and I divide it by some linear factor, x minus something, call it maybe c or something, if I divide it by x minus c, the remainder I get will be the same as the value when I plug c into the function. This is what's called the remainder theorem, and it goes along with the other theorems that we've discussed regarding polynomials and their factors and the roots of the polynomials. And it's going to just make our life a lot easier because we can utilize it in certain situations to discover different things about polynomial functions. So let's go ahead and add this, and let's write down all the theorems that we have to make sure that we clearly understand all of the linkages between all of the different components. So I've written the 3 theorems out, and let's start with the remainder theorem, which is the new one here. So for any polynomial p of x, the remainder found when dividing p of x by x minus c, and here c is just a constant, so you can go ahead and make a little a note to yourself, just any number, constant number c, is equal to the value of the polynomial when c is plugged in for x. That's just what we discovered. One way of writing this is to say, if I take p of x, my polynomial, if I divide it by x minus c, well, what am I going to get? When I do this division, I'm going to get one big polynomial. We'll call it the quotient polynomial, q. And then I'm going to get some remainder. Let's call the remainder, let's call it s. So this is my remainder here. And what this theorem says is that when you do this division, whatever this remainder is, this value s is equal to the value of my polynomial function when I plug c in for x. Okay. Now we have the factor theorem. We've seen this one, we proved it actually. For any polynomial p of x, if r is a root of p of x, then x minus r is a factor of p of x. And we've been using this for a while, and it's very, very helpful. And secondly, if we have a factor, x minus r, if x minus r is a factor, then r is a root. And so this is the linkage between roots and linear factors, right? If you know a root, then you also know a linear factor, and if you know a linear factor, then you also know a root. This one is very, very helpful. And of course, the fundamental theorem of algebra, any polynomial of degree n greater than 0 has exactly n roots. And now this includes repeated roots and complex roots. So if you have a factor that's written twice, that gives you a root, the same root twice. And counting all of those roots, including the complex roots, you'll have exactly n roots. Now there's a big thing to take away from this that we've actually been using over and over again. And if you think about what the fundamental theorem of algebra says, if you have exactly n roots, remember, every root gives you a linear factor. So if you have n roots, you also will have n linear factors. Okay? That's a very important thing to remember. So when we are working through polynomial function problems, we can utilize these theorems, the remainder theorem, the factor theorem, and the fundamental theorem of algebra, to find out some things about the polynomial functions very, very quickly. So let's go ahead and take a look at a couple problems where we can actually apply them. All right, so this first one, is x plus 5 a factor of x cubed plus 3x squared minus 6x minus 8? And explain. So before we get into this, I want you to pause and come up with a plan. How could you show or decide whether x plus 5 is a factor of x cubed plus 3x squared minus 6x minus 8? All right, so one idea is to actually do the division. So to take x cubed plus 3x squared minus 6x minus 8. There we go, minus 8. And divide it by x plus 5. And if we do that and we find that the remainder is 0, then x plus 5 is a factor. So go ahead and try that and see what you get. Now, you may have done that and said to yourself, gosh, that's a long process. Is there a way that I could have done this more efficiently? And there is. If x plus 5 is a factor, then think back to the theorems. What do we know? Well, we know by the factor theorem that if x plus 5 is a factor, then negative 5 is a root. So what we can say is that x equals negative 5 should be a root. And we can try this out and see if negative 5 is in fact a root. So if you plug in negative 5 here, what will you get? Well, you won't get 0. I'll say that. In fact, I think you're going to get something like 28. And that tells you that x plus 5 can't be a factor because x minus 5 is not a root. Now, both of these will work, but there's actually another way. We could use the remainder theorem. So if you're going through and you're doing this division, you're saying to yourself, well, I actually just want to know if when I divide this, there will be a remainder or not. How could I find whether there will be a remainder? Remember, the remainder theorem says that if you're dividing a polynomial by x minus some number, and in this case you're doing x minus negative 5, then when you plug that negative 5 into your function, whatever you get will be the remainder. So you could use the remainder theorem, go ahead and plug negative 5 in, and the value that you get will be your remainder. And so you can say, well, by the remainder theorem, this is my remainder, 28 or whatever it is. Therefore, x plus 5 does not go in evenly and is not a factor. All right, is x plus 3 a factor of 5x cubed plus 18x squared plus 7x minus 6? What I want you to do is actually choose two of the three methods that we discussed. Either do the full division, use the factor theorem, or use the remainder theorem. Choose two of them. Make sure you write out both solutions, and then we'll talk briefly about what your answer should be so you can check your work, and then we'll give you a couple to try on your own. All right, so a couple ways to do this. I really like using the remainder theorem. I just think it's really neat that if you have a factor of x minus something, when you plug that something into your function, the value you get back is the remainder. So here I have x minus negative 3. That's what x plus 3 is. And if I plug negative 3 into this polynomial, I will get a value of 0, which means by the remainder theorem that when I divide this cubic by x plus 3, I get a remainder of 0. So x plus 3 is a factor. Using the factor theorem, I could also say that when I plug in negative 3, I get 0, meaning negative 3 is a root. And if negative 3 is a root, then the factor theorem says x minus negative 3 is a factor, so x plus 3 is a factor. All right, here are a couple for you to try on your own. All right, here you go. Copy both down and complete solutions for both. If you are struggling, come up with a plan, and if you have faith in your plan, execute it, see where you go. You never know when you actually might be totally on the right track. So trust yourself, work through both, and we'll discuss them tomorrow.